Good day, everyone. Once again, we're back together and we are looking at the continuation of organic chemistry. If you haven't subscribed, please just make sure that you're part of the family. And of course, if you need to get in touch with us for any assistance in mathematics or physical science, our email address is info@mlungisi.co.za. And please don't forget, there's super thanks feature if you really want to show some love to your favorite uncle. Okay, just hit that super thanks and just make a donation of any amount that you would like to make. So let's look at question 3 from the May-June exam. And they give us a table there. They say learners investigate factors that influence the boiling point of organic compounds. The boiling point of some organic compounds obtained are shown in the table. Right, so we've got that table there. So we're going to make some comparisons. All right, so they say, first of all, define boiling point. Remember that boiling point is the temperature at which the vapor pressure, so this is the temperature at which the vapor pressure of a compound, so the vapor pressure is equal to atmospheric pressure. So it's equal to atmospheric pressure. Please, when you make a definition or rather when you write down the definition, boiling point is not necessarily, sorry for that terrible handwriting. So remember that boiling point is not, of course it is, the temperature at which a liquid turns to gas. But the correct definition, first of all, you need to mention temperature at which the vapor pressure is equal to the atmospheric pressure. Okay. Right, so in this case, we're looking at the next question. So they say the boiling points of compounds A, B, and C are compared. Now, if we look at that, first of all, how do A, B, and C compare in this case? You'd see that A is propane, so it has 3 carbons. B has 4 carbons, and C has got 5 carbons. So in this case, it means that they are increasing in chain length. There's an increase in chain length as you go down. And notice what happens. In this case, as they increase in chain length and, well, molecular mass in this case, so does the boiling point. If you notice that the boiling point of butane is greater than the boiling point of propane, right? And of course, the same with pentane. It has a higher boiling point than that of butane. So the question is, how do the boiling points vary from compound A to C? Of course, the option there's only one. They increase, right? We see that the boiling point increases. Okay, right. And then they say to you, explain the answer to question 3.2.1. Right, now in this case, please remember that we will first of all mention that an increase in chain length, we see that's what's happening, right? We know that an increase, or in fact from A to B to C, they're increasing in chain length. So an increase in chain length will increase the number of London forces, right, that are found. Or rather, you can mention that London forces increase with an increase in chain length, right? So more energy is required. So you remember to put that, right? So more energy is required in order to separate molecules, right, of C, as they increase in chain length, right? So more energy is required to separate the molecules, and as a result, the boiling point increases. Okay, I know that sounded like a lot of gibberish, but please, let's do it systematically. So first of all, we will mention that an increase in chain length will increase intermolecular forces, or in this case, you can say London forces increase with an increase in chain length, right? So we'll note an increase in intermolecular forces first of all. So what do we notice? They increase with an increase in chain length. So in this case, more energy is required. You remember to mention this every time. So more energy is required to separate the molecules of C than that of B. All right. So therefore, in this case, that is why the boiling point would be higher. Okay, so I'm just lazy to write all of that down. Okay, but please remember that is how we always try to explain that. Okay, right. The next question, they say now the boiling points of compounds B, C, and D are compared. Right, now I want you to note, so B and C, we can see that both of them are alkanes. Both of them are straight line alkanes, right? So no issues with that. There's only one difference, and that one difference is that they are both straight line alkanes, but the only difference is that they've got different chain lengths. But when you look at D, you've got now methyl butane. So in this case, it has 5 carbons, but if you were to compare B, C, and D, you'll see that now there's more than one difference. First of all, it's chain length between B and C. And secondly, now, do you see it's the shape of the molecule between C and D? Yes, it's got 5 carbons. It's got 12 hydrogens. But the problem is that now it's got a different shape. It means it's more spherical in that case. So it wouldn't be a fair comparison. Why? Because we've got more than one independent variable. Remember, when we talk about independent variable, we are simply talking about, what is changing. So look at this. Between B and C, what is the difference between those? It's definitely chain length, right? They're both alkanes. They're both straight chain alkanes. And so the only difference there is chain length. But now, if we're going to compare B, C, and D, there's 2 differences. It's chain length, first of all. And secondly, it is the shape of the molecule, right? This one has got a side chain, and the other 2 do not, whilst at the same time we've got a chain length difference. So in this case, it would not be a fair comparison, so the answer is no. And they say give a reason for the answer, because there is more than one independent variable. More than one independent variable. So independent variable. Right, so please remember that in order for it to be a fair test, there has to be only one independent variable. So it would be fair to compare B and C only, or it would have been fair to compare C and D only, but not B, C, and D. Okay, right, I hope that makes sense. Right, now the next question, they say the boiling points of the compounds E and F are compared. So now we've got E and F, we've got ethanol and ethanol, okay? Right, now that would be a fair test. Why? Because they are equal in chain length, and in this case, the only difference between them would be the functional group, isn't it? Okay, so they say to you, state the independent variable for this comparison. Remember, what is the independent variable? It is what is different between the two. And remember, what is different between the two causes a difference in boiling point. So boiling point in this case would be our dependent variable, right? As you increase, just like we looked at, the previous example with A and B, in this case, the chain length affects the boiling point, isn't it? So the independent variable between A and B would be chain length, and the dependent variable would be boiling point. Okay, right. So they said, what is the independent variable between E and F? So you can say that it is the functional group. Okay, so that is the functional group between the two. Okay, so the functional group, so that's what's different. Okay, right, and then they say to you, write down the name of the strongest van der Waals force present in compound F. Okay, now remember, F has got two van der Waals forces. First of all, you've got those London forces. So there are only two in this case. So that would be London forces. But it also has dipole. So the strongest there would be your dipole van der Waals forces. Okay, right. So, and then they say which compound, D and E, has a higher vapor pressure. Now remember that the stronger the intermolecular forces, the higher the boiling point, the lower the vapor pressure. Okay, so in this case, if I look at the two, ethanol has got a higher boiling point. It means it's got stronger intermolecular forces, right? In this case, so as a result, it means that it's got lower vapor pressure. So now let's compare. They said between D and E, so we're comparing D and E. Definitely ethanol has got a higher vapor, has got a higher boiling point, and as a result, it's got lower vapor pressure. But in this case, we wanted the one that has higher vapor pressure, so definitely it's the one that has a lower boiling point, and the correct answer should be D. Right, now they say to you, give a reason for the answer. Now, in this case, remember that D, okay, so D has got, has London or weak London forces, okay, only, all right, whilst compound E, in this case ethanol, has London forces, okay, as well as in this case hydrogen bond, right, a strong hydrogen bond. Okay, so remember that hydrogen bonds are usually stronger. In fact, they're the strongest intermolecular forces. So it has strong hydrogen bond, so H bond. Okay, so what do we know? We know that more energy would be required, right? So again, more energy is required to separate between molecules of E than that of D. So more energy is required to separate. Please don't say break bonds. We are not breaking bonds, but we are separating compounds or molecules in this case. More energy is required to separate molecules, right? Right, so to separate, sorry, I'm just going to continue on this side. The molecules of E, right? Why? Because it has those strong hydrogen bonds as well of E than that of B, than D rather, and as a result, it has a lower, so that is compound E has got lower vapor pressure. Okay, right. I hope that makes sense, ladies and gents. If you still don't understand this quite well, please just go and visit our organic chemistry playlist, and you'll see that there's a part where I really go through thoroughly through each and every one of the intermolecular forces, just to make sure that you understand that. Okay, right, I'm going to leave it there. Please don't forget to like and to share and to tell as many of your friends that, hey, your favorite uncle is doing the things here on this YouTube channel. And good luck to those of you who are continuing to prepare for the exam. I will continue just dishing out, that, important content, just to make sure that you guys are thoroughly prepared, for chemistry. And please don't forget to also just make that as those super thanks, okay, just to tell your favorite uncle that, hey, you are very grateful. Okay, and I'll see you guys next time. Sharp.